Hello, I'm Karthik Sundararaj, a technical lead with HCL. In this presentation, I'll illustrate an hybrid cloud analytics solution that we are developing for telecom service providers. This solution uses Cisco's container platform and Kubernetes service catalog to realize a hybrid distributed cloud application. This is the team behind the solution. In the presentation, I'll start with describing the business problem. Then we'll look into the solution requirements based on the problem and provide an overview on the hybrid cloud solution that we are trying to build, an overview of the prototype that we are building as a proof of concept, followed by the demo. Let's look into the business problem. Telecom service providers, as we know, serve millions of customers, and it is a challenge to monitor and ensure that customers have a satisfactory experience with the services. Service providers incur high operation costs through customer support and frequent truck rolls. Customer support is predominantly reactive. Customer reports the issue, service provider intervenes and remediates the issue. This causes customer dissatisfaction, resulting in churn and revenue loss. Service providers maintain large volume and variety of data across multiple systems, but is underutilized to add value to business. Different business units within the service provider organization work in silos, and this non-availability of integrated customer view leads to half-matured marketing efforts, unsatisfactory customer experience, and loss of business opportunities. Some of the common roadblocks from incorporating business improvements are lack of consolidated data and accurate insights, then extended cycle time to process data and delay in access to the insights. And there's heavy dependency on legacy systems to process the data. These problems are not new. Service providers have been coping with these problems for several years. We have tried to solve the problem in the past. Now we want to adopt a modern approach, incorporate the modern frameworks, the rich set of services that are offered on the cloud, and the advancements in the machine learning technologies. So some of the requirements, key service solution requirements are, first, aggregate data from a variety of data sources across different business silos and create a unified view of the business. And use the data and derive actionable insights into experience of customers with various services. Enable proactive detection of anomalies, issues, or any deterioration of quality, and help service providers remediate issues before customers report them. Predict the customers with propensity to churn and enable timely intervention to prevent revenue loss. Some of the key design considerations are as follows. Use container-based microservices architecture for flexibility and scalability. Use or adopt a hybrid cloud approach, again for flexibility to run services or workloads both on-premises and on public cloud. Service providers are keen on growing the resources on demand and not invest on infrastructure at the start. Enable seamless integration with cloud-based services for data aggregation, processing, and advanced machine learning implementation. So this is where the Kubernetes service catalog plays a critical role. So based on the above considerations, we use the following architecture components. The first component is the Cisco container platform to host these microservices and manage the lifecycle of these microservices. Then we use GCP's data flow for scalable stream and batch processing of data. We use BigQuery for descriptive analytics, and we use BigQuery ML for implementing simple predictive analytics. And we use Cloud ML Engine to implement advanced machine learning models such as deep neural networks, LSTM, GRU, and other complex network architectures built on top of TensorFlow framework. In summary, we are building a container-based hybrid cloud analytics solution that will help customers help service providers to understand their customers better. And it is intended to provide a unified view about the end customers and help improve the services and grow the business. So some of the salient features of the solution are, as I mentioned before, aggregate data from across a variety of data sources, blend the data, and then transform them into actionable insights. Track the customer's experience, track customers' footprints, and identify hotspots for cross or upsell. Provide forecasts into future trends, generate alerts, notifications, and enable service providers to perform proactive actions. So we wanted to first experience building hybrid cloud applications using Cisco's container platform and Kubernetes service catalog. So we decided to implement customer churn analysis and prediction as a prototype, as a proof of concept. And the scope of this prototype includes aggregation of data, because data is a critical part here. So first, aggregate data from different sources, which includes billing systems, customer support systems, service usage monitoring, CPE telemetry data, and so on. Then create an integrated view of the customer data and analyze churn. Implement a simple churn prediction model using hybrid cloud service. So we use the following tools and services: Cisco container platform for CI/CD as well as management of microservices lifecycle, PubSub for data aggregation, Data Lab for data exploration, Data Flow for stream and batch processing of data, and BigQuery for analysis and BigQuery ML for churn prediction. A critical aspect to the success of machine learning is the right selection of features. So with respect to customer churn prediction, we have identified all the relevant factors that influence the customer churn. It includes the frequent service disruptions that the customers have been experiencing in the past, how often they contact the customer support, what kind of an experience they have been getting from the customer support, then what the competitors are offering, and any billing discrepancies that they may have encountered in the past. So these are a few examples of the features that we use to arrive at the prediction. This slide provides a high-level solution architecture. So we have several services hosted on premises, and we exclusively use the cloud for implementing machine learning. So we have data sources, which are heterogeneous systems. We collect data from those using a collector microservice. The collector microservice does some level of cleanup and ensures that the data privacy is not violated, and it extracts the features of interest and publishes to the cloud. The collector service interacts with the cloud service seamlessly using the Kubernetes service catalog. Now, once the data is published onto the PubSub, then it is fed to data flow jobs, which do further processing, derive the features and the metrics, and then store the data in the BigQuery. This data residing in BigQuery is then consumed by a periodic machine learning job that trains the model, updates the model frequently, and then generates the forecast. Once the forecast is available, periodically the analytics service residing on premises will again use the service catalog and access the data store service on the cloud to download the forecast data and make it available for UI. The UI microservice will consume both the historical data as well as the forecast data and help the service providers analyze the churn and predict churn. This slide presents the data pipeline or the data flow within the system. So the data gets published. There is some pre-processing before the data gets published onto the cloud PubSub. The data gets processed on cloud data flow. Then it gets stored in BigQuery, picked up by the machine learning job. The model is built, forecasts are generated, and the data returns back to on-premises for consumption. For development of the services, We leverage the CI/CD mechanism offered by the Cisco Cloud Cisco Container Platform. So this shows the typical CI/CD pipeline that we use for our development and delivery of the solution. Now let's look into the demo of a prototype.